Now this here is our second discussion of LCDs, part 2. In part 1, we just talked about finding LCDs of straight up numbers, and now we're going to talk about how to find LCDs for things with variables on the bottom. So we'll start out with something like, say we wanted to add this kind of a thing. Okay, whatever you want to put here. We're not going to actually talk about how to add this, but we will talk about how to find the LCD. So if you didn't see part 1, you definitely need to go find that. So find the LCD of, because we're going to use the same strategy, x and x squared plus 4x. So we're still going to do the same thing we did when we just had numbers. We're going to factor. So x doesn't factor that, interestingly. X equals x. Doesn't really factor in anything. But we can factor x squared plus 4x because we can pull an x out and we're left with x plus 4, right? Hopefully. So if we want to find the LCD, we can do the same thing we did with numbers, except now we're going to line up entire factors. So x is just going to be expressed as x, but x plus 4x is going to be expressed as x times x plus 4. So we can do what we did last time is we'll line up the independent factors and we'll just pull down whenever we can. So the LCD of x and x squared plus 4x is actually going to be this, where this turns out to be, and it turns out to be x squared plus 4x. So we're going to use the same basic strategy and just make it work. Let's try to find the LCD of 3x plus 15 and x, how do I want to say that? Let's go x squared plus 10x plus 25. All right, so that one's even more fun, right? So we've got 3x plus 15. We want to factor that out to pull out a 3, I guess, and we've got x plus 5. And if we factor this guy out, do our little FOIL thingy, reverse FOIL, x's and 5. So if you can't factor, you can't find LCDs of these kinds of things, just so you're pre-warned. All right, so we've got everything factored out. Now we're going to line it up. So 3x plus 15, we've got a 3, and we've got an x plus 5. Now for x squared plus 10x plus 25, we've got an x plus 5. We don't have a 3, so we don't line anything up there. And we have another x plus 5. So to find the LCD, we see what lines up, oops, and what doesn't. And essentially, we're going to multiply these together. So the LCD is going to be 3 times x plus 5 times x plus 5. You could probably leave it like that. If you're truly desperate to multiply it out, you can, but it's not going to win you any friends particularly, but it might make you kind of cool. So that would be the LCD if you wanted to express it like that, but this is good enough right here to call it that. But that'll give you a way to calculate the LCD. Let's try something kind of similar. Let's try find the LCD of, I like this one. We'll do this one. X squared minus x minus 6 and x squared plus 3x plus 2. So we've got x squared minus x minus 6, and we're going to factor that out. X and negative 3, negative 2. Again, if factoring is not your strong suit, you're going to need to go practice that before you can find these LCDs, because they really depend on the fact that you can factor. So x and x, and that'll be 2 and 1. So we're going to do the same thing again. We're going to line things up. This one's going to be x minus 3 times x plus 2 This one is got an x plus 2, so that one will go under that one. And it's got an extra x minus x plus 1 there. So to find my LCD, I go x minus 3 times x plus 2 times x plus 1. If you just want to write it like that, that's definitely sufficient. So you can kind of go all over the place with this. It's actually kind of fun finding as many of these things as you want. We'll do one more just to make sure it's kind of sort of there. At least you got a couple more examples. Try find the LCD of try x squared plus 5x plus 4 and x squared minus 16. So again, we're going to go through here and factor stuff out. So that'll be a 4 and a 1. This is the difference between two squares, so that one's not too bad. Yay! And so now I'm going to put them together and line them up. So I've got x plus 4 times x plus 1 over here. My second one got an x minus 4. That doesn't line up anywhere, so it goes off by itself. And the x plus 4 lines up under here. So draw stuff down. So I've got x plus 4, x plus 1, and x minus 4. So that's going to be my LCD there. So that's kind of fun. We'll try, I lied, we're going to do one more. Not like it matters, you can turn this off anytime you want. Let's find the LCD of, let's do 10x, x, and I don't know, how about, I like 5x squared. You can do it all over the place, and 2. There we go. So you're really going to multiply all these out. So 10x is going to be 10 times x. X, I mean, you can find the LCD of as many things as you want. So x would be just x, and that lines up, so that's good. 5x squared. Oh, you know what? I could do this a lot better. I'm crazy. So 10x could be 5 times 2 times x. There we go. That makes sense? 5 times 2 times x. 5x squared, because I didn't have it down in my prime factors because I'm a doofus. Yay! So 5 goes under there, under that 5, and then I have x squared, so that means I've got 2 x's. So that one doesn't get to line up with anybody. And then my last one is a 2, and she just lines up right here. 2 is a girl, apparently. So I've got things lined up where I can, and extras are kind of out on the side. That's okay, because I'm still going to use them. So it doesn't matter that I have 3 x's, because they all kind of line up. And as long as I line up, I only have to count them once. But here was an extra guy. So my LCD is all those multiplied together. So my LCD is 10 times x squared, or 10x squared. And that was a rather quick but generously fantastic introduction to finding LCDs.